Hello everyone, and in this episode of the DBot build series we're going to be having a look at the firmware, from how to configure it in the Arduino IDE to the connections that we make on the ramps board for the BL Touch / 3D Touch. I'm Jay and this is my 3D adventure. Okay, so here we are inside the Marlin firmware. So basically, if you was to go to the Marlin website, marlin.org I believe it is, but there'll be just a link in the description, and downloaded Marlin, this is what you'd be faced with. Now obviously I've input all of my settings for the DBot, and we're going to go through them in a second, but you can also download a copy of the DBot firmware from the Thingiverse page. But what you've got to obviously remember is if you're using different auto leveling sensors, different pitch lead screws, or even different numbered tooth pulleys, they'll all have an effect on settings that you input. So if we head over to the configuration.h file, and this is basically where you set up all your parameters. So if I just scroll down here, so the first thing you can do is basically put a name in here to show that you've edited these settings and they're specific for you. So if we keep scrolling down, now a lot of this stuff you can just sort of go past it, it's already sort of configured. Serial port is fine, board rate, you basically whatever you set here, as long as you set the same in whatever control software you're going to be using for the printer, that will be fine. Here is where you would specify the motherboard that you're using, or the control board, and we're just using a ramps. An EFB stands for extruder fan bed, and they are the connectors on the ramps board for where you would plug in basically an extruder, a part cooling fan, and a heated bed. And there are different combinations of those. So I think there's EEB, which is extruder bed, or possibly EFF, so you can have extruder fan. So just basically have a look and see what configuration you're using. The next part here, if you're using an LCD screen, which I am not in this case, but if you were, you can define custom machine name, and that little display at the bottom when you turn the printer first on. So the next option is number of extruders. So in my case we're just using one extruder. Filament diameter, I set that. I don't think it has much effect for the setup I'm using, but always good to put that in. This stuff we can go past. This is to do with multiplexing extruders, switching extruders, single nozzle extruders, and etc. Next option is power supply. Again, unique to your own setup, but typically most people will be number 1 ATX power supply, or 0 no power switch. So define whatever you have. Thermal settings now, depending on the hot end you're using, will depend on what thermistor you'll have. Now a typical, if you were using off-the-shelf E3D V6, you would be using number 5. However, I am actually using an old Ubus, or Printable Ubus thermistor, so mine is number 7, and my bed thermistor is just a 1K beta, and that's the number 11. Dummy values not important, although you can use those if you wish to test for motor movement before you set everything up. I did actually do that, just make sure that I've got the right thermistor, or thermistor won't make a difference, but make sure that the movements work, and sometimes the firmware needs to think that there's a temperature for it to do that. So make sure that's something you can play around with. Okay, so this next section here is to do with thermal protection, and it's basically all to do with how quickly, or how it measures how quickly the temperature goes up in a given time, and by a certain amount. So again, stock settings are pretty much fine here. Next section, minimum temp, maximum temp. Again, depending on your hot end, if you've got a light 6, for example, you won't go anywhere near 300 degrees. Bed temperature, again, depending on what heater you're using, etc. So put those in. Next section is PID settings. So I'm only using PID on the hot end, and these are my values from a PID tune. Again, yours will be different, even if you're using exactly the same hot end. It has a lot to do with the heater cartridge, the environment you're in, etc. So always do a PID tune when you first set up your printer. Very important to do. Next section is bed temperature control. I'm not using PID tuning, I'm using WhamBam. It's something I might play around with, but at the moment it's fine. It heats up and it cools down, so it does what it needs to do. The next section here is to do with the extruder, and it's entirely up to you really if you have it selected. I potentially should have it defined, but through other firmware that I've configured, I've always disabled it because I've sometimes used the 2 extruder into 1 nozzle, so you need to have prevent cold extrusion off. But again, I think stock settings has that on, so maybe use that. So there's another section here dedicated to thermal protection runaway, or thermal runaway protection. Always have that defined, no question about undefining it. Next section, so a CoreXY printer needs to be defined as such, because of the way that the firmware will control the stepper motors. Now here we have the end stop connections and their settings. I think if you was to follow the DBot guide, then these are what you want. So you want to use the X-min, Z-min and Y-max. So define those ones. Next section is pull up resistors. Excuse me. Again, stock settings has them turned off. And then here is where you would set whether the end stop triggers when it's normally open or normally closed. Most standard, so these are probably the most standard settings, depending on the type of end stop you've got, but I think if you followed the BOM for the DBot, then that will be fine. So the next settings are the important ones basically. These are your steps per millimeter, feed rates, acceleration, etc. So going by how my pulleys are set up, the type of lead screws I've got, the Titan extruder, etc., or the Titan clone extruder I should say. So I use 80 by 80 steps per millimeter for the X and Y, 400 for the Z, and I've calibrated my extruder to be 462 steps per millimeter. Again, another important thing to configure for yourself when you set up your printer is your extruder calibration. Some brilliant guides online. I think Tom's 3D has done one, so I'll put a link to that in the description. The next section is to do with maximum feed rates. Now these are my settings that I've tweaked to get to. These will be different from the firmware that you would have downloaded from the DBot page. These are just what has worked for me basically, so have a play around with them and see what works best for you. Okay, so next part again different settings from stock because these are what I have worked out. Maximum acceleration, I'm going for 1500 by 1500, 30 and 4000 steps per millimeter, or steps, sorry, steps, yeah, millimeters a second I should say, sorry. So again, these are what have worked for me. These are the other acceleration settings: retract and travel. Jerk settings, again, I should say actually that some of these settings are ones that I've copied over from excuse me, the firmware that Spire has sent me. He's the gentleman that I printed a lot of the parts for my DBot. Links to his parts on Thingiverse are in the description. He sent me his firmware via email so that I can configure mine. So thank you to him. So if we scroll down, the next section is to do with the bed leveling. So again, this will all depend on your particular setup. I'm using a bed leveling sensor. Stock DBot is just an end stop for the Z. So these will be slightly different, but you will always use basically an end stop for your Z min. So that is defined. And then if we scroll down here, this is where you would select what you're using. So I'm using a BL Touch, or in my case a 3D Touch, the same thing. If you were not using a BL Touch, 3D Touch, or an inductive sensor, you would have probe manually selected here, defined. And that is basically you turning screws that compress or release springs on the corners of the bed. So there's a few settings to go along with a 3D Touch. I think again mine are kept as stock settings. I haven't changed any of these. The next part here is the offset from extruder, and again these are defined for me by the part that I downloaded from Spire, and he very kindly on his Thingiverse page has put the offsets. Now I've got my Z probe offset here as 0. He has his as I think minus 2.06 or something similar. That I will explain that later, but that's just because I configure mine through G-code rather than in the firmware. The next thing we have is basically how fast the printer will send the probe around the bed to take measurement. I actually need to try and speed mine up because it takes quite a while to probe the bed. Next part here is the clearance for the probe. Again, I can tweak these a little bit. I was just going on the more conservative side for making sure I didn't hit anything. So this is the code that I use in when I'm setting up the probe, M851. And basically what this allows you to do is if you set in the firmware the clearance or the offset as 0, you can then with G-code sort of define how far away the probe is from the nozzle. And actually Joe, the 3D Making Noob, did a good video on that, and there will be a link in the description for that. So go and check that out because I used it myself and it worked perfectly. So go and check that out. So the next section here is basically to do with step direction and whether you have to change them or anything like that. So again, depending on your setup, this is what you've got to do basically. Home and direction again is defined by if you've built the DBot as stock. So the next section again here, size of the print bed, again depends on what size DBot you built. I went for the larger of the two DBot configurations on Thingiverse. So that's 300 by 300 by 325 on the Z. And you just define those settings here, basically. If we scroll down, a lot of this you don't need to really worry about. If you're using a filament runout sensor, you would define that here. So this part here is the way that the probe is used to actually level the bed. So I have bilinear auto leveling set up. I'm not using a fade height. That's something you can set in. You can even set it in your start G code if you want. But basically what that does, as I understand it, is that if you don't have that defined, the Z-axis steppers will independently change as you're printing on the same layer to ensure that you're always level. And basically what you can do is with this this setting is basically stop it doing that after a certain height. Again, I'm not using it. If you want to, you can define that here. A lot of these settings you can just go past. The most important part here is the probe position relative to the size of the bed and anything that might get in the way, and that is the areas that the probe will go to take a measurement, or the maximum distances it will go to take a measurement. So with the leveling we have set up, what it will actually do, if I can find the correct setting, so here it will take the size of the bed and then subdivide it up and take a number of probes across the bed. So I think with the 300 by 300 it takes 9 test points basically and uses that to create a mesh. So that was the bilinear setup. The rest here are again different leveling options, and depending on what you choose to use, you will define and configure those there. So next thing I have defined is safe homing. And basically what that means is if I tell the control software, whether it be Simplify 3D or Repetir Host or whoever, to home all axes, what it will do is it will home X and Y, and then rather than just measuring Z where it's gone to X and Y point, it'll actually go to the middle of the bed, so you'll be clear of any clips that you may have holding glass down or anything like that, and it will take the Z measurement from the middle of the bed. So that's basically what safe homing is, and you define that with basically dimensions here. And then you've got your homing feed rate. Again, depending on your setup, depends how fast you want to go, basically. I haven't changed any of these settings, so up to you whether you look at them. So EEPROM and EEPROM chit-chat are basically the settings that have to be enabled for you to use G-code commands in the terminal and get information back from the printer. So have those enabled or defined. And then you've got a number of settings here that decide whether things are kept active and how long they're kept active for. Again, if you're using an LCD, you can set up predefined temperatures for preheat settings. I'm not, so I haven't got any of those set up. I haven't got a nozzle park feature set up or nozzle clean. So the next section is to do with LCD. I haven't got one, so I'm actually going to skip past that so I can get down to the servo section, which is what I have to define for the BL touch or the 3D touch. So before I actually get to that part, there's a couple of things here that may be of interest to people. You can define status LEDs, and this might be something that I do a video on much further down the line if I look at adding some LEDs. And there's also a pin that you can define to take a photograph. Oh, so I think what it will do is if you have the camera connected to this pin, it'll actually trigger the shutter at a certain point. So you can do some cool things with that. It's got, I do have a Blink M, and it's like an RGB LED. I've never really played around with it, so this is quite an interesting piece of information here. I may look into that. Again, not at this stage, so we'll just go past it. But again, RGB LEDs if you wish to do them. So we'll look at all that. So here we have servo setup. Now the servo setup is what you also have to set up if you're using a 3D touch, BL touch, or a auto leveling probe that is driven from one of the servo connectors. And we will have a look at the board in a second, the ramps board in a second, to see how those are, where they are on the board. So you don't have to define 3 servos, you can actually just define the one if you're only going to use one thing. I've just defined all 3 just to have it done already. So you would select how many servos you wish to define, and then the delay. So if you just had 1 in here, you would just have 300 set down here, and that is it. So that is basically the firmware that I am using for my DBot. I was going to use TMC 2130 chips. So if we just have a quick look at those settings, I was going to use them, but I was having problems with one of the chips, and I think that may have been when I soldered it, because it was causing troubles on another printer as well. So, but if you had TMC 2130 chips, this is, you'd go to configuration_advanced.h, do a search for 2130, and that would basically bring up this section, which would allow you to configure those settings. Again, Tom3D, done a video on it, link in the description if you wish to add those. So that is pretty much it for the configuration on screen. We'll now have a look at the the ramps board over on the printer, and I'll talk about how the servo connectors are basically hooked up for the BL touch or the 3D touch. Okay, before we actually go and have a look at the ramps board, I just want to have another look at the leveling probe settings within the firmware, because I was asked a question on Instagram about how I set up the BL touch or the 3D touch. So I'm just going to have a look at that in more detail. Now, like I say, I used the extruder mount from Spire, which has got placement for the BL touch already in the file. He gives you the offsets, etc, etc. Now, when we go back over to the printer, I will touch on a thing that I found with my 3D touch, and that is basically the length of the pin when it is in its retracted state. Now, I was having issues with that pin being very close to the bed when the nozzle was on its first layer, and I actually lost a couple of prints because it hit parts of the print that had been laid down, and actually either knocked the whole thing off or caused the extruder to skip and start printing off the part. So I will have a look at that in a second. There is actually a set screw that you can adjust to make that change, but let's have a look at the firmware. So this may have been different in older versions of Marlin, but basically all you have to do is, so this would be undefined when you first downloaded it, and you literally have to just undefine it, go down to the servo part, set those up as you wish. Like I said, 1 servo or 3 or whatever. And then I have changed nothing else. Now I have changed this delay because I'm having sort of a strange issue, but to be honest, I don't know what this does or how much of an effect, or how much I would have to change it to see a noticeable effect. But in terms of actual firmware settings for the BL Touch, it was literally to define that line here and go down and define the servos, and that is it pretty much. I think they've done a lot of work sort of that you can't see, that sort of automatically selects certain things and sets servo degrees for the pin, which we'll have a look at. But basically you define that section there, define the section on servos, and then you are good to go in terms of firmware. So let's set up the camera and have a look at the physical printer. Okay, so before we have a look at the ramps board itself, I thought I'd just show you the homing procedure, and this will demonstrate the safe homing option, and as well as the 3D touch actually in operation. So if I just zoom out slightly so you can see me operating the control, and I'll zoom it in as it does the safe homing Z measurement. So if I was to press the home XY, it's actually already in homing position, but that basically takes it over to the back left corner. And if I then press the home Z, you can see that it moves to the middle of the bed, deploys the probe. Let me just zoom in a bit. So you can see that the probe there is deployed, and the bed is now being raised up to take that measurement. So if we just give that a second, and I'll just see if I can move this camera slightly and zoom in. Now that is one of the oddities that I'm having. It's almost like a double probe in the space of a few seconds. So if anyone knows how to change that and how to fix it, then please put that in the comments. I will be very grateful. But as you can see, it's done its double touch effectively procedure, and it now thinks, or it now knows where Z0 is, and it's raised up to its 15mm safe height, which is on at the clearance height, I should say. So what I'll do is I'll just home the X and Y again, and I'll zoom out so you can see that in operation. And now effectively the printer would be ready to preheat and go ahead and print basically. So let's have a look at the ramps board in more detail, and where we plug in that 3D touch. Okay, so let me apologise in advance if this footage is a bit shaky. I'm actually going to do it handheld so I can really get you in on the detail. So you can see here, this wire here, not this one, these are the connections coming from the 3D touch up on the X gantry that plug into the servo connector. So these small headers here, okay, so these headers here, these are our servo connectors basically. So we've got in the first servo connector, we have our connections coming down from the 3D touch, and they are basically ground, 5 volts and ground, which are the first 2 pins. Then the bottom pin is signal. I'm not going to get too close, but hopefully you can see the silk screen on the board there. And the other connections coming from the BL touch, or the 3D touch, are what go over to our, let's see if I can get that to focus. No. So over in this corner, so these 2 leads here coming off the bundle, is our Z min end stop connections. So the end stop in this case is the 3D touch. So that is where they plug in onto the ramps board. So let me put the camera back on the tripod and we'll have a close look at 3D touch and actually see it in operation. Okay, so what I've done here is set up the camera so you can see the 3D touch in operation. So I've basically just homed the printer again like I show you. And if I tell it to home Z, what it will do is deploy the probe and then slowly bring the bed up to take the measurement. So let me press the home Z button and you can see that operation. Okay, so what you saw there was the probe deploy, the bed raise up to do its first touch, which then caused the probe to retract. The bed then lowered, it retracted again and did a slower rise to trigger that probe again. So when you do a bed leveling procedure, what that will actually do is do that 9 times at 9 different points along the bed to give you your mesh. So what we can actually do within Octoprint, there's actually a plugin for the BL Touch. Now this is obviously a 3D touch, but it works the same. So what I can actually do is deploy the probe manually, so you can just see there where it comes down. Now one of the problems I said or mentioned that I was having was that the probe, when it was in the up position, was still quite very low, in fact too low to the print bed relative to the nozzle. So you can also actually just do a self-test, and I have to confirm that, but what that does is basically trigger the probe so that you can see that it's triggering correctly. So I'll just stop that. There we go. So basically what I had to do, and this is going to be a little bit hard to show you because everything's installed, but let me just take the camera off the tripod again, and then hopefully this will focus here for me. There we go. So this, as you can see, this is a printed part that Spire released on Thingiverse, and this basically allows you to mount the 3D Touch or BL Touch probe in a certain distance away from the nozzle. Now my pin, when it was deployed, or when it was retracted, sorry, was very close in height to the nozzle. So what I discovered was, actually by looking on the documentation for the BL Touch, excuse me, is that I took the probe off the mount, and in the very top of the probe is a set screw. Now I just thought that this held the pin in. I didn't think there was any sort of adjustment going on. But given the information for the BL Touch, it tells you that the set screw should actually be a certain height from the top of the plastic casing. And mine was actually way off, which meant that the probe, when it was retracted, was too low. So by adjusting that set screw, I've now got the probe, when it's retracted, to be about 2 millimeters above where the nozzle is. And I have not had any problems with the probe hitting a print since I've changed that setting. So what I'm just going to do is actually try and get you, I've just turned the fan on. So I'm not sure if you're about to see this, but this is the BL or the Touch UI that I use to control the printer. So I'm actually going to show you the homing procedure from the screen. So I would press that, The printer then goes to its XY position, and if we come back and press the home Z, you can see that the carriage goes to the middle of the bed, deploys the probe, and then does what I just showed you basically. And there was that double tap again, and I'm not entirely sure why it does it. Again, if you know, please put it in the comments section so I can fix the problem. So what I will actually just do is show you sort of the full depth of the Z. So I've got it currently set to 100, so we'll lower it by 100 millimeters. It does take quite a while. What I actually need to do is get some anti-backlash nuts. Let me just try and focus this in for you. There we go. Because what happens, and I'll actually try and demonstrate it for you. So as you can see, 100 millimeters is already quite a good depth. But if I go back over here and press this button, that disables the motors. Now, if I just very lightly push on this bed, that obviously moved. And now I'm not touching it, and it's lowering itself. Now I think that's purely because of the weight of the bed. So let me just stop that and I'll tell it to go up 100. So yeah, I'm hoping that anti-backlash nuts will actually help with that. That was a comment on the Facebook group, so that will probably be the next thing I upgrade. But other than that, I am very happy with how this printer has come out. I've done a few little updates by putting fans and MOSFETs etc. on, but in terms of firmware, which is what this video is about, what I show you, the settings I show you were basically what I'm using. I've got a Raspberry Pi here running our Octo print, so I'm just going to give you a close-up video of the screen for anyone who might be interested. So I actually really like this setup. I've customised the UI as well to sort of follow the colours of the channel, but other than that, it's really easy to use now, which I think is brilliant. So yeah, so I think we potentially will have one more video, perhaps maybe a sort of time-lapse / montage of some prints that I'm doing on the printer. But other than that, that is pretty much it for this build video and series. If you have any questions, please put them in the comments, either in the comments section or in on Instagram or Twitter. All the links for my social media are in the description. Just want to say a last massive thank you to the sponsors of this series. So Oosnest for the aluminium extrusion, the whole frame they sent me, to Filament for all the filament they sent me, so that was the two spools, the red and the white PETG, and also to Triangle Labs so they sent me the 3D Touch, the Titan clone extruder, a pack of nozzles and a filament runout sensor, which is going to be a separate video review. So yeah, please like, comment and subscribe, and I'll see you next time.